Hey, what's going on, folks? It's Mike here, and welcome to our next lesson in the modern C++ series. In this lesson, we're going to be talking about something known as a functor. This is something that's been around in C++ for a long time, and it's going to make sense to talk about it because we've actually got something that makes it a little bit easier to work with functors in modern C++, lambdas, which we'll eventually get to in this series. But with that said, I want to go ahead and talk about what functors are. They're actually really useful, and they're nice building blocks for composing larger programs. That said, before we begin, I just want to do a quick shout out to all of our members supporting the channel. Thank you for supporting this series, and then all of our new subscribers, welcome aboard. So with that said, let's go ahead and dive into this lesson. All right, so what I've got here is this idea of a functor. And you can kind of tell just from looking at the name, it has something to do with a function. And tor, I don't know how to explain that other than it sort of sounds like object or constructor. So we're constructing objects out of functions. It's a function object. And in fact, that's what it stands for. And basically what this means is that we're going to be able to create or sort of think about using an object like a function. But as we know, objects are things that have data and actions associated with them. So in other words, if I can clear this up just a little bit, a functor is an object, or rather a function, with state. And the key for holding this state, or rather using an object like a function so that it can store its data, is operator parentheses. Okay, so we're going to go ahead and see how we use this to create a functor. Okay, so let's go ahead and just start with the basics, and I think this will make sense as we progress. So what I'm going to go ahead and do is just create a struct, and the struct is going to be a little bit easier to work with today, and just create some sort of object here. Now, the typical examples that folks use here are just going to be things like holding a number or a value or something, and that's what we're going to start with, and then I'll show you something a little bit more pragmatic. But what I'm going to go ahead and do here is just create some sort of value. So here is some object here, and let's just go ahead and have it hold some result here. And in fact, we'll probably want to initialize this to some value here. Let's just initialize it to 0, and let's hold on to that for now. And then because we want to use this object like a function, well, we're going to overload operator parentheses here, and then we can supply any parameters we want here. So this is going to be the perhaps new result here. Okay, and what we'll just do from this operator here is just return the new result and set our result equal to new result here. Okay, now typically when I'm designing my classes too, I also like to prefix my variables with m underscore. So let's just go ahead and do that. And we need a return type here for our operator, and I'll go ahead and save this much. And let me just do one quick little cleanup here, make sure my parentheses are aligned, and that I've got a semicolon here. And let's go ahead and compile this. So go ahead and compile this with C++20, but again, just to show my point that this is something that's been around for a while, let's go ahead and just do this in C++98. Now, if I do this in 98, it's going to complain about these curly braces here. So let me go ahead and get rid of those and compile this. And again, you can see that this is a feature that's been around for quite some time. But let's go ahead and remodernize our code here and make sure that we have everything there here. Okay, so now how do I actually use this value object here? Well, let's go ahead and create one here. So I'm just going to call it value v here. And again, let's go ahead and now use this. So because we've overloaded the parentheses here, I can actually just call v and then the parentheses, and then go ahead and pass in some value here, like 42 here. And let's just go ahead and print out v, and we'll go ahead and do the result here. Now, again, I've just made everything public to make things relatively simple. But if I go ahead and run this program and run it, we get the value 42. Okay, so this is where we have this sort of is a function with state here. Okay, so what do I mean by function? Well, just look how we're using this at line 16. I just have this function, and I mean, this looks like a function call here. It's not a constructor. That's the other time where we've seen objects with parameters, but it's just sort of standing alone, and we're able to provide some input for the arguments here. In this case, value 42. But what's interesting is that it's holding the state here. It's actually holding the result here in one of the member variables, this sort of data member here. Okay, so that's where we get functor from. Okay, so now you might be asking yourself, why might we actually use this sort of functor? Well, there's actually a couple reasons that we might want to do this. Let's say that we have perhaps a bunch of interesting results that we want to store in here. Okay, so a result, and I'm just going to sort of label these generically 2, 1, and so on. But what if, for instance, I'm only able to set one of these at a time? Perhaps I've got 2 processes running. So what I can actually do is create another operator here. And just to make this a little bit more interesting, let's just make this a different data type here. I'll make this a float here. And if we happen to pass in a float here, this will be for our result number 2. Here's our result number 2. And let's go ahead and make sure we return that. And we'll go ahead and return a float here. Okay, now what's going on here is, well, you're saying, Mike, you've just overloaded operator, and we know in C++, we haven't talked about it too much on this channel, but we can overload these operators, and this will call the float version, setting result 2. This will call the int version, so calling and setting result number 1 here. And this doesn't seem like a big deal at first. So let's go ahead and do it here. Now let's just go ahead and create this as 42.7F, and I'll be explicit so it calls the right version. And let's go ahead and print things out here. And I'll do v.m result 2, and go ahead and recompile this. Whoops, made one little error here. Let's see. It is that I rename these to result 1, so I got to just go ahead and fix those. So I'll do that at line 10 here, and at line 24. And let's give that another recompile, and I'll rerun it. And my lack of spacing here, let's go ahead and put a comma between these here, just to show the 2 different results here. And there we have it. Okay, 42 and 42.7. So again, you might be saying, well, what's the big deal here? Why were we able to, compute these different results here? This is sort of like just having a function that takes multiple parameters, or even an object where I just have perhaps 2 different member function calls that set these member variables here. And again, you're completely right. Those would be other strategies that we could use. But what if I have to start passing this function into, or this object rather, into multiple other functions? Or if I want to be able to compute different results on a different thread, and sort of, the point is here that I'm able to partially compute a result here and store the state here while this functor, or this function object, is computing and storing the results here, okay? So it allows us to sort of break up work and sort of partially solve problems, okay? So this is a bigger idea in functors that I think is just kind of neat. Now, with that said here, I'm gonna go ahead and just show you this example so you can see all the code here. And then I wanna go ahead and just show you another example that I think will get you to maybe buy in and see that functors are kind of neat here. And the tool that they're going to allow us to build and use later in C++, lambda functions, unnamed functions, is what's essentially built on top of a functor. So we got to understand this first. All right, so here's the code. Here's what we did here with our struct here. We did the operator overload here with parentheses, and we computed 2 different results here for our functor. Now, again, we could have done this in one function. I could have made this 2 parameters, but I wanted to show you how to break this problem up. Okay, so with that said, I want to go ahead and save this source code. Let's go ahead and make a second main here, and go ahead and show you another example. Okay, so let's just go ahead and prepare this. So we'll get ready to compile main number 2. Still the same example here, but I'm going to go ahead and give you something maybe a little bit more realistic here. So this time I'm going to go ahead and create a new struct here, and I'm going to create a goblin here. Okay, and let's just go ahead and give it an attribute like health here. So I can imagine some sort of game here where you're attacking some goblins. Now, what I want to go ahead and do is initialize a vector of these goblins. Okay, so I'll call this goblins. And let's use a list initializer here, again, pulling out some of our modern C++ here to just construct a bunch of these goblins here. Okay, so I'll have a goblin, and I should provide a constructor here, and this will be good review for us in this series here. Let's go ahead and do a goblin here and provide health here. I'll just abbreviate it as H here. And let me follow my convention by prefixing my variables with an M at the least, sometimes an M underscore. And we can take advantage of move assignment here when we construct this object here. Okay, so that's our goblin that we have created here, or a constructor for it. And let's give them some health here. This first goblin has 5 health. The next one's got 3. The next goblin's got 100 health. Maybe that's a boss or something. And so far, so good. So let's go ahead and compile this. No mistakes. Okay, so what do I want to actually do with these goblins? Well, maybe, and again, you can imagine in a game context, you want to target the weakest goblin first and attack it. So you can imagine some sort of system where we want to sort these goblins for whatever reason. Okay, so let's just go ahead and using our algorithm library, we're going to use the sort function here. Okay, so what I'm going to go ahead and do here is call begin on our goblins and end on our goblins, which provides an iterator. So pointing to the front of our vector, that's what this is doing, and pointing to the end of our vector, that's what this is doing. Now we will talk about some STL in this series later on, so you're going to have to subscribe to make sure that you don't miss that. But let's just go ahead and leave this as is here. I'll go ahead and compile here. And okay, I'm getting a bunch of errors here. So we got to kind of figure out what's going on here. Well, first and foremost, let me not jump too far ahead. So we can either use Cpp man, which is a really nice plugin, and look for the standard sort function. Or for those of you who haven't seen my video on Cpp man, which I'm just going to go ahead and shut that down, let's go ahead to our other favorite website, and I'll bring in Cpp reference here. And let's just go ahead and look at standard sort. Okay. And what sort's taking is, well, an iterator for the first and the last item, which we have here. Okay. We're taking in the first and the last thing. But the issue is, how are we sorting these goblins? Well, we probably want to sort them by their health, right? That was our original goal. So what I'm going to need to do is overload again using operator and then the less than operator. And then I'm comparing my goblin that's going to be essentially to the right, the next one over. So let's go ahead and say goblin and the right hand side. And this is going to return a Boolean if this goblin's health here is less than the right hand side's goblin's health. Okay, health here. Okay, so let's go ahead and see if that helped us out here. And looked like it did, but we just need to return here true or false. All right, from that expression. Okay, so now if I run this, no result yet, so let's go ahead and print this out. And let me go ahead and just show you the code so you can see it on one line here. And let's go ahead and break this down here just to make it a little bit nicer so you can see all of our goblins being initialized. And then I can make this a little bit bigger. And let's just go ahead and print these out here. So let's just go ahead and while I'm introducing new things here, let's go ahead and print out our goblins. I'm just going to refer to them as G from our collection. And again, I'm throwing, for those of you who've been watching this series consecutively, some new things at you, but this is a range-based loop, which we've talked about in the series a while ago. So I might need a refresher here. And let's just go ahead and print off our goblins by their health here. And we'll go ahead and put it in end line. Okay, so if this is working, if this sort function is working, which needs some way to compare goblins, and it's using their health, and we have an operator less than. So again, what's going on in this sort function is it's looking from the start to the end, and it's essentially just comparing these using some sort of search or sort algorithm rather, and we have a way to tell what is or how is a goblin less than some other goblin, in this case, the health attribute. Okay, so let's go ahead and save this. Let's go ahead and compile, see if we made any mistakes. No mistakes. So we should see the goblins sorted in this structure 3, 5, and 100. And in fact, we do. Okay, so this works great here. Okay, now what I'm going to go ahead and do is say, well, I'm making a more interesting game. So again, imagine this fictional problem where I'm trying to target the weakest goblin. Okay, I've already sorted them, but there's other properties that goblins have. Maybe their strength, for instance. So let's go ahead and add another attribute here, strength. And we'll go ahead and say S here. And we want to establish their strength here. So let's go ahead in our initializer here. And let's give them, these two will be equal. And let's go ahead and make this one very weak. So it's got a lot of health here, but maybe we want to just, take care of it later to say, or earlier. It doesn't really matter. But let's go ahead and compile this program again here. And one mistake here, so I've got to fix. I've got to put a comma here because I'm initializing multiple member variables here. And again, it's still working, but again, I want to be able to sort by the strength now. So I'm attacking the weakest goblin first for whatever reason here, okay? So what we're going to go ahead and do here is, well, I can't exactly use another operator here because I have to choose here. I've only got one goblin that I'm comparing against. Essentially, that's what I'm doing. And you can kind of imagine this problem if you've ever done Excel or database programming where you might want to, or even just looking through statistics, say in some database where you're trying to sort by, say, two categories at once, okay? Two attributes. So in this case, we might want to sort by the health or the strength, or maybe even a combination of the two actually is a better way to do this. So let's actually, just to make this a little bit more interesting, what I'm going to go ahead and do is let's increase the strength of these ones by quite a bit here. And I actually want to sort by the combination of their health and their strength here. So what I could do here is, again, just add the health and the strength and maybe use that as a comparison. But again, maybe that algorithm's not going to work very well and we want to change things around. So let me get to the point here and create a functor, which we've been learning about here. And usually we call this sort of a special instance here. I'm going to call this comparator for the goblins. So goblin comparator. And what I'm going to do here is I'm going to create a functor, okay? Just like we did. And why I'm doing this, well, when we look through a lot of the standard library here, again, this was the sort function that we were able to call. But we, again, want to be able to use some sort of third argument that can do a test here to help sort us. And that test here is basically a comparison. Is the left-hand side or the right-hand side greater or less, okay? And you can see that we have this sort of compare overloaded version of sort here. So this third attribute here that we can implement. And that's what we're doing here with goblin comparator, okay? So let's go ahead and we're going to return some Boolean here. And because this is a functor, again, the operator that we are overloading is the parentheses here. And we're going to take in a goblin again. I'm going to make these consts because they're not changing, pass them by reference. And we're comparing the left-hand side with the goblin on the right-hand side. And again, there's some things that we might want to do here just to, make our code nice here. We could make this const, for instance, just to be, none of the member variables are changing in this particular comparator. And let's go ahead and now do our comparison. And again, it's got to return true or false here. So I'm going to say the left-hand side. And let's actually just use the strength attribute now. I'll just use one of these. Less than the right-hand side strength here. Okay. And let's go ahead and just return this. And it's just a true or a false value here. And again, this time for my sort function, I want to do a different test. So I'm just going to pass in my goblin comparator here. Okay. So let's go ahead and see if this works, if it's as simple as that. So I'm going to go ahead and compile. Let's see, it looks like I'm missing a semicolon at line 18. I thought I'd get it perfect, but there's always one little thing here. but it does in fact compile and it runs here, okay? And now we can see how our goblins are being sorted not by their health here, but essentially in reverse order. So this one here with the lowest strength, but the highest health is first, and then the next one, and then the next one, and then the next one. Okay, so we can kind of see how I could use different comparators or this idea here of different tests here as parameters into functions that change our behavior, meaning how we are changing how we do this sorting function. Now, what we're going to find is there's actually a lot of different algorithms here, which is what sort is part of. And I've omitted this explicitly calling out, but they're part of the algorithm library, which is going to be a really important part of the standard template library. And that's where we're going to be moving in a little bit after we talk about some more of the containers in this series. So I hope that was useful. I hope that sort of motivates functors, these functions with state or function objects, if you will. They're really useful in the sense that we can use them as building blocks for solving larger problems. Whether you want to think about the previous example, which I'll bring up here, just as we recap here in our main, where we can sort of compose or partially solve some problem if we want for a larger object, or just simply for convenience, have a function that we can call and record state. A lot of times folks will also use these just to have counters for how often functions are called, or writing little test functions. And then the other case, which I find myself more often using for functors, so let me go ahead and open up what we just solved here, is when you want to do some sort of comparison or a test here. So you could imagine, again, some object with multiple attributes, and you want to write some way to compare them or evaluate them. Well, you can just have several different overloads of this operator parens here. Okay, folks, so with that said, I hope this was an interesting lesson that opened your eyes into functors. They sound kind of scary when you first learn about them, but this should give you a nice introduction to what they actually are and how to use these functors. So with that said, hope you enjoyed this lesson. Hope you learned something about functors. If you have comments, even if you're just not happy about goblins with the least strength and the most health being attacked first, go ahead and let me know, and we can discuss that in the comments, and I'll look forward to that. All right, with that said, folks, thanks for your time, and we'll talk to you soon. See you in the next lesson.